Hi, I'm Cohen McConnell, and this is AP Stats Quiddeo number 5. The basic question says, here are estimates of the daily intake of calcium for 38 women between the ages of 18 and 24 years who participated in a study of women's bone health. Part A asks us to display the data using a histogram and describe the distribution of calcium intakes for these women. According to my histogram, the data is skewed right with potential outliers at 2,433 and 1,933, which you can see here over on the table. Part B asks us to calculate the mean, the standard deviation, and the standard error. I found the mean to be 926, the standard deviation to be 427.2, and the standard error to be 69.3. Part C asks us to find a 95% confidence interval for the mean. Now, whenever you hear 95% confidence interval, you're going to have to think pants. And that means you're going to make out that big, long abbreviation. So starting with P, P for the parameter is the women's average calcium intake. A is for all of our assumptions, and we can assume independence and simple random sample. And because n equals 38, and 38 is greater than 30, we can also assume normality. Next, we're going to have to name the test. And since there aren't two values, we know that this is just a t-test. And t-test will be x bar minus the mu over standard deviation over the square root of n. We're going to find our df by subtracting 1 from 38, which will make our df 37. Now by plugging in our values for the t-test, we will find that our t value is 2.042. Now we'll do our confidence interval formula. 926 plus or minus 2.042 times 427.2295 over the square root of 38. By plugging in these values, you'll find that the interval will be 784.5039 to 1027.5487. Now that we're at our S, we can finally make our statement, which is that we are 95% certain that the average intake of calcium for women is between 784.5039 milligrams and 1027.5487 milligrams. Part D asks us to eliminate the two largest values, aka our possible outliers, and recompute the 95% confidence interval. And what do we notice? Degrees of freedom of 30. Now we're just going to re-plug in our confidence interval formula, and we will have 856.2 plus or minus 2.042 times 51.1. And that's going to give us a confidence interval of 751.9 to 960.5. And that is the end of the basic question.